Alzheimer's is weird. A person is born, they live their whole life, they meet people, experience things, and then as time passes, they start to forget like everything.
Everything all right?
Who are you?
Actually, it's me, Paul.
Who?
I live here.
What is this nonsense?
There is no definitive cure of Alzheimer's. But there has been some interesting development in this field. Alzheimer's is a common cause of dementia, but it's not a normal part of aging. Alzheimer's is a specific brain disease that accounts for 60 to 80% of dementia cases. On the other hand, dementia is a general term for symptoms like decline in memory, reasoning, or other thinking skills. Alzheimer's keep getting worse over time. Alzheimer's is a progressive disease where dementia symptoms gradually worsen over a number of years. In late-stage Alzheimer's, individuals lose the ability to carry on a conversation and respond to their environment. Alzheimer's is the sixth leading cause of death in the United States. On average, a person with Alzheimer's lives up to 4 to 8 years after diagnosis. Changes in the brain related to Alzheimer's disease begin years before any signs of the disease. This time period, which can last for years, is preclinical Alzheimer's. At first, let's look at what causes Alzheimer's. Alzheimer's disease has two main antagonists in its story. Amyloid beta is the first one. Amyloid precursor protein APP helps neuron grow and repair itself. Alpha secretase and gamma secretase recycles APP and turns into soluble chunks that can be used for other purposes in body. Beta secretase creates insoluble fragments called amyloid beta. Beta amyloid plaque is created when these monomers all add up around neurons. These plaques get in the way of neurons and disrupts signaling. This causes serious issues in brain function. These nasty plaques also kickstart immune response. Microglia handles the waste management in our brain. When they suck in the amyloid beta, they get activated by a triggering release of inflammatory cytokines that can damage other neurons. The third thing this amyloid beta can do is just hang around the blood vessels in brain. Just put a little pressure on it and one day, out of nowhere, you've got a hemorrhage. This step is called amyloid angiopathy. Neurons need nutrition, and nutrition is carried around using cytoskeleton. They are orderly parallel strands for delivering key materials to the cells, and cytoskeleton is held together by tau, our second antagonist in the story. Amyloid beta affects the tau protein and tau changes its shape, gets out of the cytoskeleton and bundles up to create a tangle, popularly known as neurofibrillary tangles. Neurons with tangles are pretty much useless, so they end their sufferings themselves by a programmed cell death, also known as apoptosis. Plaques and tangles tend to spread through the cortex of the brain in a predictable pattern as Alzheimer's disease progresses. This rate of progression varies greatly. On average, a person with Alzheimer's lives 4 to 8 years after diagnosis, but can live as long as 20 years depending on other factors. The course of the disease depends in part on age at diagnosis and whether a person has other health conditions. Brain's wobbly outer shape has some higher bumps and lower dips. the bumps are gyri and the dips are called sulci. In brain atrophy, the brain shrinks, making the gyri narrower and creating much more deeper sulci. Also, the ventricles carrying cerebrospinal fluid or CSF becomes much larger. An important discovery to the path of curing Alzheimer's is CMA or chaperone-mediated autophagy. Chaperone-mediated autophagy is a cell cleaning process. It helps to get rid of beta amyloid plaque and defective tau proteins. CMA becomes less efficient as people age, increasing the risk that beta amyloid plaque and defective tau proteins will accumulate into insoluble clumps that damage cells. There is a dynamic interplay between CMA and Alzheimer's disease. Loss of CMA in neurons contribute to Alzheimer's and vice versa. So, by increasing the efficiency of CMA may offer hope for treating neurodegenerative diseases. CMA is capable of digesting defective tau and other proteins. But the sheer amount of defective protein in Alzheimer's and other neurodegenerative diseases overwhelms the CMA and essentially cripples it. A magical drug that can revitalize CMA efficiency by boosting levels of key CMA components can give us a cure of Alzheimer's. In CMA, proteins called chaperones bind to damaged or defective proteins in cells of the body. The chaperones ferry their cargo to the cell's lysosomes. Lysosomes are membrane-bound organelles filled with enzymes which digest and recycle waste material. To successfully get their cargo into lysosomes, chaperones must first dock the material onto a protein receptor called LAMP2A that sprouts from the membranes of the lysosome. The more LAMP2A receptors on lysosomes, the greater level of CMA activity is possible. The new drug called CA works by increasing the number of those LAMP2A receptors. You actually produce the same amount of LAMP2A receptors throughout your life, but those receptors deteriorate more quickly as you age, so older people tend to have less of them available for delivering unwanted proteins into lysosomes. CA restores LAMP2A to youthful levels, enabling CMA to get rid of tau and other defective proteins so they can't form those toxic protein clumps. Researchers tested CA in 2 different mouse models of Alzheimer's disease. In both disease mouse models, oral doses of CA administered over 4 to 6 months led to improvements in memory, depression, and anxiety that made the treated animals resemble or closely resemble healthy control mice. Walking ability significantly improved in the animal model in which walking was a problem. And in brain neurons of both animal models, the drug significantly reduced level of tau protein and protein clumps compared with untreated animals. So, successful treatment of Alzheimer's might not be a distant future, and hopefully forgetting precious memory will be a relic of the past.